Alright, hey everyone. Today we're going to start looking at fractional indices and surds. Now, fractional indices are a brand new thing again, so I'm going to take a little bit of time to run you through how we can think of these. And I'm going to introduce you to an idea of a surd, but we're not going to go too far into surds because the next video is going to give you a much more in-depth thing. But I want to show you particularly the reason we're doing this all together is because we're trying to relate these two ideas. Now, let's consider a fractional indice. Now, you don't have to know how these work just yet. This is just so we can think of how these could possibly work. So say I took 9 to the power of a half. Now, I don't know what that is. That's fine. But say I multiplied that by 9 to the power of a half. If I treated this like any index laws question, well, I would see that these two numbers have the same base of 9, and there is a multiplication of these same base indices. So this thing is going to be the same as 9 to the power of a half plus a half. Because our index laws tell us that when we multiply here, we're going to add the powers. Now, half plus half gives me 1. So this gives me 9 to the power of 1, or just 9. Now, can we think of another two numbers that multiply, that are the same, that multiply to give me 9? Well, we've talked about square roots before. And we've said that to find a number that multiplies to give me some number, the square root would be the number that times by itself. So, in other words, I can say that the square root of 9 times the square root of 9, anytime I multiply these two together, square roots together, it's going to give me, the answer is going to be the number inside the square root. We've covered this before. Please watch one of those videos if this is new. But I can say then that the square root of 9 times the square root of 9 also gives me 9. So there's something to be said with these things relating, because these are both the same number. They multiply to give me 9. These are both the same number. They multiply to give me 9. So there's something special about how these relate. Now let's look at one more example, because this could just be a coincidence. Now, if we consider, let's look at, we'll go 27. Let's have a look at this number 27. And let's say I took 27 to the power of a third, and I multiplied this a couple of times. So I've got 27 to the power of a third. We looked at fractions in the previous example. We looked at half. Now let's look at a third. And let's see what this gives us. So, let's say I have these three indices all multiplying by each other. Now, once again, these are multiplying. So, that means that that's going to equal something with the same base, and we are going to add the three powers all together, because that's just what our index laws tell us. That gives me 27 to the power of the third plus a third plus a third. And when I add 3 thirds all together, I'm just going to get one whole again. So that gives me 27 to the power of 1, or just 27. Now, can we think of 3 of the same numbers that can multiply to give me 27? Because here we're looking, we had 3 separate things here as opposed to 2 in the previous example. So we want to think, well, is there a number that multiplies by itself 3 times that gives me 27? Now you may have to do a little bit of trial and error and mess around with this on your own if you'd like, or I'll explain it now in a second. But here, I can think that 3 times 3 times 3, gives me 27. Or that 3 cubed gives me 27. Now, what does that mean? Well, if you remember back to when we talked about squaring and cubing, I could say that once I have this, so like I did up here, once I have 9, I can find the square root of the number, and that'll give me 2 numbers that multiply to give me 9. In the same way, when we think of cubing something, we can consider this 27, and we can find which 3 numbers multiply to give me 27 by taking what we call the cubed root. So we can say that the cubed root of 27, that's what this 3 tells me, the cubed root of 7 is going to be 3, because it tells me what 3 numbers, which are exactly the same, multiply to give me 27. So that's this 3 here. So what I'm going to do is, instead of writing this 3, I'm going to substitute the cubed root of 27 in its place, because these are exactly the same. So you saw what I did up here. I'm going to do a similar thing, but using this notation. So what I've essentially established is that the cubed root of 27 times the cubed root of 27 times the cubed root of 27 also is going to give me 27. So there is a relationship between this, once again, with this. So, in the same way as we had here, we can say that those are kind of looking like they're the same, right? So I'm just going to make a note of this down here. I've made an observation, and you can try this with any other numbers if you'd like to get more crazy with it, but I've established that it appears as though 9 to the power of a half is the same as the square root of 9. Now with square roots, we can write this as just our general square root notation. We can also write this like this, the square root of 2. The 2 means it's a square root, but by convention we don't really do this for whatever reason. And we can also say that 27 to the power of a third is the same as the cubed root of 27. Now, what have we actually noticed here? Do you notice anything peculiar? Let me pop this 2 back here just to see if it looks a bit more clear. Well, it looks like whatever number is on the denominator here ends up being the level of rooting we're doing. Here we are finding the square root. And here I'm finding a fraction of a third, so the denominator is a 3, so I'm taking the cubed root, or the third root. So, from this, we can state that any number to the power of a fraction, with whatever denominator we have here, that is going to be equal to this denominator as the root of my base number here. So this is the main relationship we observe with fractional indices. Now let's apply this to some questions. We're going to try to evaluate some numbers. We'll write them first, converting them from fractional indices to using a radical sign. By a radical, we just mean this root sign. And we're also going to look at index laws with these types of questions as well, with fractional indices. So let's look at question 1 over here. I want to write the following numbers using a root sign or a radical sign. So we have 6 to the power of a half here, and for B we have 2 to the power of a fifth. Okay, so we noticed from our previous examples that whatever the denominator is of our fraction, 1 over something, that's going to be the level of rooting we do. Let's put it that way. It's going to be the degree that what our square root is going to be. It determines whether it's a square root or a cubed root or the fourth root or the fifth root, etc. Right? So 6 to the power of a half, my denominator is going to be the level at which I've taken the radical or the root. And my 6, my base, is going to go in here. So I can think of this as the second root of 6 or the square root of 6. And we can just write a square root without this 2 as well. So that's how we can express that there. And we do the same thing for the next question. This 5 here, this time, is going to be a degree of my radical here. And the 2 ends up going inside that radical, inside that root. And we can do this for any other question. And we can also take this one step further and actually use this to more easily evaluate things, right? So one particular example is going to be if I take 144 and I want to find what 144 to the power of a half is. So once again, I'm going to take my denominator, and that's going to determine that I'm taking the square root of 144. So I'm finding which two numbers multiply to give me 144. And if you know your times tables, you can probably figure this out without using a calculator. But you can also just pop this into your calculator, and you're going to see that you will get 12 as an answer. Because 12 times 12 gives me 144. So the square root of 144 is just going to spit back the number that had to multiply by itself, which is 12. Now, let's look at using index laws here. This is our last set of examples. We want to apply what we know about fractional indices to using index laws. And you'll see that we can also just as easily simplify the multiplication or division of indices like we have with our previous examples in this topic. So if I have a to the power of a half times a to the power of 3 over 2, here I'm multiplying same base indices, so the powers here are going to add. So that's going to give me the same base, and I get a half plus 3 over 2. When I add a half and 3 halves, I get 4 halves. So I get a to the power of 4 over 2, which then gives me, what's 4 divided by 2? That gives me 2. That gives me a squared. That is my answer here. So the index laws still apply to our fractional indices in the exact same way. So you don't have to worry when you see these types of questions. We work through them in the exact same way. Now, another question we have here, is question B, is what would be x to the power of a half divided by x to the power of a third? Well, when I divide same base indices, I'm subtracting the powers. So I have x to the power of a half minus 1/3. Now, when I subtract fractions, I want to find the lowest common denominator. That is the common denominator for both of these fractions. We want the same denominator and then just compute this. So that's going to give us a half I can make into 3/6, and a third I can make into 2/6. We've done this a lot in the past, so that's why I'm working through it a bit quicker. Please consult the previous videos if you want some more revision on adding and subtracting fractions with different denominators. But now I wind up with x to the power of 3 minus 2 gives me 1, and 6 is my denominator. So my final answer is x to the power of 1/6. Now, final question I'm applying a different type of index law to what I've done so far. I'm doing y to the power of 2 to the power of 1/4. So when we're taking the power of a power, remember, we are multiplying these two together. Multiplying the two powers. So that is like saying y to the power of 2 times a quarter. 2 times a quarter gives me, I can write that as 2/4, or I can write that as y to the power of half. Now, as a little bonus round as well, how can we write this with a radical? Well, I can write this as, remember, the denominator here ends up being the degree our radical goes to, the amount of roots we've taken, and my base number goes inside this. So my answer can be either y to the power of a half or the square root of y. I can either write this like this or like this. Now I notice we haven't talked too much about surds just yet, so we'll leave this video as fractional indices and these square roots we're dealing with, and a few of these previous examples. These are what we call surds, which we're going to talk about in the next video. But thank you so much for joining me, and I'll see you there.